Suppose ABCD is a quadrilateral in which AD is parallel to BC and AD is equal to BC. So the distance from A to D is equal to the distance from B to C. So here is our quadrilateral A, B, C, D. We're told that AD is parallel to BC and that the length of AD is equal to the length of BC. Prove that ABCD is a parallelogram. So I've drawn it out separately down here, A, B, C, D. I'm going to start by joining B to D. So B to D. So joining up the two vertices. And I've created the triangle ABD and the triangle DBC. So as AD is parallel to BC, so AD is parallel to BC, I've drawn in the two red lines to show that, the two red arrows. By alternate angles, angle alpha is equal to angle beta. So angle alpha, I've done in green there, is equal to angle beta. I've also done in green. So we have our two parallel lines and a transversal cutting through, and these angles are alternate to each other, so they are equal to each other. So angle alpha is equal to angle beta. Also, we are given that the length of AD is equal to the length of BC. So the length of AD is equal to the length of BC. And BD is common. So we have a common length of both triangles. So BD. So that's obviously going to be the same. Hence, the triangles ABD, ABD, and CBD, CBD, are congruent, which means they're identical. 3 equal angles, 3 equal sides. And they're congruent by SAS, which stands for side included angle side. So we have a side, an included or an inside angle, and a side. And then we have a side, an included or an inside angle, and another side. So since we have proved congruency by SAS, we know that all the other corresponding angles and all the other corresponding sides are also equal. Thus, the angle ABD, so ABD, so this angle here in blue, is equal to the angle BDC. So BDC, so this other angle here in blue. And so, by alternate angles, AB is parallel to DC. So AB must be parallel to DC. Because if we were to extend our parallel lines, AB and DC, and BD was the transversal cutting through them, if this angle is equal to this angle, then they must be alternate. So these two lines must be parallel. Hence, ABCD is a parallelogram. Because we were told in the question that AD is parallel to BC, and we've just proved that AB is parallel to DC, so therefore the shape must be a parallelogram.